Hello dear students, welcome to Learning Chemistry is Easy and Fun, a channel dedicated to all the learners of chemistry who want to understand chemistry no matter what the age, what the learning level. If at the end of the video you like it, please don't forget to subscribe and share it with your friends. Besides structure of atom, you will find many other topics on this channel and new are being added every day. Today's lesson number 14, Heisenberg's uncertainty principle. As we said, we discussed earlier in lesson number 12, this was one of the objections raised to the Bohr model of the atom. What is Heisenberg's uncertainty principle? Heisenberg, of course, as the name indicates, was the scientist, was the physicist who actually gave this concept. Uncertainty, when you are not sure as to how it is going to be. So when you say what are the marks that you are going to get in your next chemistry test, so you're unsure. You say you could get between 70 and 80, 80 and 90. So there is always a probability, but you are not very sure. You can't say for sure, yes, I'm going to get 82. Yes, I'm going to get 96. Principle. Now this is something which is universal and this was given in 1927. What does the principle state? What is very, very important is the language of the definition that we have written over here. And I am going to stress on those points so that when you write it also, it should not hold you from getting good marks, because that's the ulterior motive why you are here, right? In order to improve your learning as well as improve your score. It is not possible to determine simultaneously the exact position and momentum of a subatomic particle with absolute accuracy or certainty. Now what does this law state? It says that you cannot, first of all, for a subatomic particle, now see the language of the definition. We are not talking about macroscopic objects. We are not talking about this pen, the board, the chair, the table, you or me. We are all macroscopic. We are being governed by the Newtonian laws. Subatomic, very, very small particles with a very small mass. It is not possible to determine simultaneously. The word is simultaneously, at the same time. You cannot determine the position, the exact position, right? You can definitely get an idea, but you cannot determine the exact position and momentum of a subatomic particle. So we are talking about position and momentum, subatomic particle, and we are also talking about not being able to determine it simultaneously with absolute accuracy or certainty. That is why it's called as the uncertainty principle. So you cannot be sure that okay, this is the nucleus, this is where my electron is located, because that is what Bohr had said. He, if you remember, we had determined also, he had calculated the radius of the first orbit, the second orbit, and so on for a hydrogen atom and given us accurate values. We have dealt about this in our previous lessons. If you are not able to relate at this point, please try going back to other lessons in order to understand the Bohr's concept. Heisenberg said that when you are trying to determine the position of the electron as well as its momentum, you are incidenting high frequency photons onto this electron, which when they get reflected is what you are observing. This was his thought process, okay? So this is what you are observing. But when you are incidenting these high energy photons onto the electron, definitely because of its small mass, you are not getting the correct position, because the electron will now get displaced from its position, right? So this was the thought process behind this whole definition, although it has been proved to be correct theoretically as well. And the description or the explanation of this is beyond the scope of this video as well as this level. I wouldn't want to confuse you more, but try and understand. If I am talking about a small object and I am trying to observe, how am I observing this pen is when light photons from this are getting reflected and reaching my eye. Because of its mass, there is no displacement. So I will see it where it is, right? On the other hand, when the mass of the particle is very light, when I am talking about a mass as low as 9.1 into 10 to the power minus 31 kg, if we incident high energy photons onto it, it will get displaced from its position. That is why in this definition, the words like simultaneously, position, momentum, subatomic particle and accuracy are very, very important. These are called as the key terms, especially when you are preparing for examination. So if you say it is not possible to determine the exact position and momentum, now what word have I missed out here? Yes, I have missed out simultaneously. So my definition will not make sense. Coming to the mathematical aspect of Heisenberg's uncertainty principle. If delta x is uncertainty in the measurement of position, delta p, now if you remember we've already spoken about p where Bohr gave us the concept of quantization of angular momentum and he had said that there is a fixed value to the angular momentum of an electron. So delta x into delta p, P stands for momentum, delta P is uncertainty in the measurement of the momentum of the electron, is greater than or equal to h upon 4 pi. In other words, if you are measuring this accurately, in other words, if there is no discrepancy in the measurement of the position, then there will be a high difference in the measurement of momentum. Again, we say momentum is the product of mass and velocity of a body. So replacing delta P by m delta V. Now why have I taken m delta V? Because m, that is the mass of the electron, has already been determined with accuracy in our earlier experiments. So it comes down to delta x into delta V is greater than or equal to h upon 4 pi into m. So you have mathematically two expressions for Heisenberg's uncertainty principle. You can list them either way, but make sure that you give the meaning of the terms that you have used when you are giving any mathematical expression, be it Heisenberg's principle or de Broglie concept or Planck's equation. Wherever you write a mathematical formula, don't forget to write the meaning of the symbols that have been used, and these are all standard symbols. Mathematically, let us see how Heisenberg's uncertainty principle is not very much applicable to macroscopic objects, but is very much valid for microscopic ones. For example, electron. Electron has a mass of 9.1 into 10 to the power minus 31 kg. Planck's constant, I am taking an approximate value of 6.6 into 10 to the power minus 34. If you are very particular, you can take it as 6.626 as well. Now can you pause the video and determine the value of delta x into delta V for me using these values? Again, pi is 3.14. Also, you determine the value of delta x into delta V for you yourself as a macroscopic body. So you can take mass as equal to your mass and determine the value of delta x into delta V. Please pause the video, try it yourself. You'll find the class much more interesting. Yes, when you determine the value of delta x into delta V for a subatomic particle, it comes approximately as 5.7 into 10 to the power minus 5, which is in sharp contrast to the value that you get for a macroscopic object. Now for a microscopic object, you cannot ignore this value. Whereas for a macroscopic object, it is very, very small. It is to the tune, like for example, in this numerical, I have taken mass as 50 kg. So this comes to the tune of 1.05 into 10 to the power minus 36, which is a very, very small value compared to when you are talking about a microscopic object. So all this actually brings us again to the de Broglie concept, that which says that electron has wave as well as particle nature. It would be in your best interest that if you want to understand these topics more clearly, you teach. Try to help other students of your group or your class or anybody who needs help in these topics. It could be even your junior who needs help in understanding these topics. Believe me, when we teach, the understanding is much more better because you are thinking as well as teaching. Hope you like the channel. Do become a subscriber and stay in touch. Happy studying, all of you.